To create a new project in ML Studio, you go to File, New, Project. We want the AVR Assembler project, and down here we can name it whatever we want. So we can do Lab, Demo, Example. Click OK. We have to select our device, and so here you can choose the ATmega device family, narrow it down. We can look up ATmega 328 PB, and that is our device. And so here you can also find the device page in the datasheet, and it'll load a new project through that. Now we will need to replace all of the default code with the code that we've actually written for this demo. And we can try to run it after setting a breakpoint, but we first need to select our debugger/programmer, which we can do the simulator for now, which will allow us to run it. And now we can set up a list of watch values to look at certain registers. So in this case, we're going to be watching R23, R24, R25, R26, R27, R29 for some reason, R30, and R31. And so we will be watching these registers as they change. So first we are loading R26, or we're loading the decimal number 2 into R26 and the decimal number 3 into R27, which, because we've already passed that line, you can see it down here is already 2. And if we skip to the next one, now R27 is 3. We're loading 1 to R30, which it is now, and 7 to R31. Now we are adding the 2 that's in R26 to the 1 that's in R30 and storing the result in R30. And as we can see, R30 is now changed to 3, which is 1 plus 2. We are now subtracting the 3 stored in R27 from the 7 stored in R31, which should give us 4 that we will then store in R31, which does happen. And now we are multiplying the 3 in R30 with the 4 in R31. And now the result of that is, the high result of that is stored in R1, and the low is stored in R0. So we're just going to take the value from R0 and copy it to R30, which then gives us our result of 3 times 4 is 12 in R30. Now we are clearing the R30, we negate the R30 register, which swaps all of its bits, which makes it a really big number because we had a really small number, 12, compared to what the register can actually store. And now after that, we are going to clear the register, which sets it back to 0. Now we are going to transfer the number 4 that's stored in R31 to the SRAM data space at 0x200, which we can do. And now we are going to take that from that data space and store it and transfer it into R30, which is currently empty. And so now it has 4 because that's been stored, and now we've loaded it from the SRAM data space. So now we are going to copy the data in the R30 register to the R29 register. So R29 should also be 4 after this, which it is. And now we have reached a new label called equal. And here we are just adding R26 to itself, which gives us 4. And then we are comparing R26 to R30, the value of each, and it is comparing 4 to 4. And so it says branch if equal to equal. So if R26 and R30 are equal, then the 0 flag will go off in the status register, which it does over here, which means that they are equal and the branch will execute, and so we will return back to the equal label. And so we do that, and now we add R26 to itself again, which gives us 8. We compare them. Are they equal? No, because that 0 flag is not set anymore, and so it doesn't branch back to the equal label. Now we are going to, and that's a conditional branch. And now we're going to execute an unconditional branch, which is just a simple to skip to. And that means we are going to skip this operation of adding R30 and R31, and we're just going to go straight to the skip to label, which if we execute that, that is exactly what we do. And now, when we are at that skip to label, we are setting the carry bit in the status register, which means that it will light red. And now we are going to clear that carry bit in the status register, which means it goes back to 0. And now we are going to swap the 2 nibbles in the 8-bit register R31, which means we're going to swap the first 4 bytes with the last 4, which will give us a bigger number, 64, which makes sense. And then we reach a new label called do until, which we are going to use to essentially keep jumping through this loop until the value of R30 is equal to R26. So currently R26 is 8 and R30 is 4. So if we keep looping through this, we are going to increment R30 by 1, which makes it 5, and then compare the two. And then is 5 equal to 8? Nope. So we keep going through the loop. And we continue to do that until it is 8 now, which incrementing R30 has given us 8. And so now they're equal. And now, because we're branching if they're not equal, we will no longer branch until do until. And so we've completed that loop. And then here, we are just loading some decimal numbers to act as counters, target number of loops, and a factorial value. So we're going to calculate the factorial of 5 using a for next loop. And so here we're loading 0 to act as a counter to R25. We are loading 5 to R24 to act as the target number of loops. And we're loading the number 1 to R23 to serve as the factorial value being calculated to store that value. And so once we do that, we get to here. And so now we have 1, 5, and 0. And we do nothing here just so that we can have this comment that says that we're calculating the factorial of 5. But we increment R25, which is our counter. So then our counter becomes 1. And we multiply the factorial by the counter. So we have 1 times 1. So it'll still be 1 after we copy it over from R0. And then we compare the counter in R25 to the expected 5 loops that we stored in R24. And here 1 is not equal to 5. So because it's not equal, we are going to go and branch back to the for next loop label. And so after that, we repeat the process. Now we are incrementing R25 to 2. We are multiplying R25 and R23. And then we are going to copy it from the R0 register for where it's stored to R23, which is our factorial value. And now that we've got 1 times 2, it is 2, and so it's R23 has changed its value to 2. And so now we compare and repeat the process until now we have 6, 24, and 120, which is the factorial 5. And now because the R25 counter is equal to the targeted 5 loops that's in R24, then we will not loop back. We will not branch to the for next. And so we will continue. And now here, we are just looping to prevent executing our arbitrary code. And that is the end of the program.